I would like to start now. Hope you all can hear me. Good morning, good evening. Thanks for joining the session. Today I will discuss about the weather company and IBM Business, how they use the advanced technology to provide the weather forecast across the world. Um, Before starting, any questions are welcome. Please put them in the Q&A section. You can write any questions. I will try to take them in between. Otherwise, in the end, I will try to address all the questions. With that, I would like to start now. So today I'm going to discuss the application of AI, cloud, IoT, and high performance computing in weather forecasting. So weather forecasting has a lot of data, then it requires, advanced techniques like AI. The solution is provided through cloud. Now IoT is also there, and certainly weather model needs HPC system to make forecast in time. So before we starting, I would like to start with a video. It's a advertisement video. Company shoot on me. I became the hero here, but there is a message about weather company in that. So yeah.
ये लो खाना।
अरे इतना सारा खाना, पर आपके हाथ का अचार।
धूप निकलेगी अभी तो अचार तैयार है इस मौसम का। बार बार छत पे भाग। अगर ऐसा मौसम रहा ना तो एक दिन ये भी खत्म हो जाएंगे।
मेरे पास एक इलाज है चाची, ये देखो।
फोन पे?
हाँ, धूप कब निकलेगी मतलब आम कब सुखाने, सर्दी कब पड़ेगी मतलब घुटने कब बचाने, ये सब आपके फोन पे।
ये सब तुम्हें कैसे पता है?
मेरी कंपनी है ना, उसका ऐप है ये। मौसम से हम सबको फर्क पड़ता है चाची। पता हो मौसम कब बदलेगा तो हम कई चीजों की तैयारी कर सकते हैं, आपके अचार की भी।
अरे वाह, तू तो कमाल का वेदरमैन निकला।
Weather is a hidden layer of insight that can predict how we feel and the decisions we make, the foods we crave, and how and where we satisfy our appetite. We drink more fizzy drinks when it rains and eat more yogurt when it's windy. Indoor paint sales increase when there is above the average wind. Hand and body lotion sales increase when there is no cloud coverage. Auto gas sales spike when temperatures are colder than average. Arthritis and COPD can increase on specific days. You can get an advance warning and not miss medication. The Weather Company and IBM Business acts as your personal weather advisor to help you plan your day, when to go for a run, swim, or play cricket. Organizations can now use weather events and emotional triggers to better serve customers, impacting lives across India with 15-minute forecasts available every 500 meters across villages and districts in India.
So before starting, let me brief about myself. I am a PhD from Indian Institute of Technology, Delhi. I did PhD in applied mathematics, where I developed the mathematical model for the dispersion of air pollutants, which I run them on the high performance system and did the scalability analysis on IBM, Sun Solaris, and other system during PhD. Then I joined IBM in 2010, where I was a HPC application specialist for the initial 2 years. Then I was part of IBM Research, where I got a chance to work in IBM UK at client site. Then I was a technical computing leader from 2015 to 2017. And right now I am a technical lead and senior meteorologist, the part of weather company from 2018 onwards, and I take care India and South Asia region. So let's talk about the weather company, how it works, what it does, and how the advanced technologies are being used. So before, so first thing first is what is the input and then how it gets the output. I mean, what is the input to make weather forecast and how it is derived. So weather company has their own approximately 200,000 weather station across the world. They get input from there. Weather company doesn't believe in one weather model, so they run at a time around. They have their own model which they run on their system, as well as they take the data from across the world, various organizations like European Meteorological Organization, um, and then NCEP, and there are many other organizations across the world. So around total 178 forecast model are being used. Ensemble of those models being used to derive the forecast at the given location. We have, so for vertical data, the weather company have tie up with various airlines where we give data, weather data to airlines for their scheduling and routing the flights, as well as we get the data from the flights as they, when they fly, they have the sensor, so they give back the readings of the weather in the vertical atmosphere. The last is the example of IoT, where nowadays we start taking the data from the mobile phone. A mobile phone with the weather channel app can provide us pressure reading, temperature, pressure, wind, and humidity. In general, we know that with mobile, person may sit with air condition, so the temperature and wind may not be correct. So we take only pressure from those mobile. Now, pressure in the given area, if all many mobiles at one location, the pressure will remain same. And based on that, those pressure reading being used as a data simulation technique in the weather model, where we check the accuracy of the model as it progress for the forecast, and we correct it over the time, right? The Now the next thing come is very important, is how frequently the forecast gets updated in our database. So we update the forecast in every 15 minutes in our database. Every time one gets the refresh forecast. Accuracy wise, as any software developed, the Gartner gives the rating for the accuracy. The weather company forecast is being give checked by independent agency called Forecast Watch, which evaluate all the private agency provided forecast, and IBM Weather Company is the number one in that. Precision wise, we have coverage across the world, so there is no issue any place in the world we have coverage. This slide we show tie-up in segment. So the weather company is well known and it has tie-up with the so there we have on Apple, the default is weather channel app. On Google, if you search any weather, the first result come from weather.com. In India, we have the tie-up with the leading newspaper, Times of India. There is the Samsung phones, high-end phones, they have a default weather channel app. There is a Facebook, Yahoo, they use the weather.com weather, provided weather, and then CNN that also use the IBM provide weather, right? Now the next, in this slide, I would like to discuss about the data and how big the data being supported and on round the clock, right? So weather requests across the world can be asked anytime in the day. And the number of calls what we support in a day is around 26 billion per day API request. Now the competitive scale for this is on Google, what we do the search, everyday search, those are around 6 to 7 billion search and on a given day. So our volume to address the weather query is around 4 to 5 times more. Then we ingest every day the 24 plus terabyte of data, and then based on those data we derive the solution of weather solutions. So now the weather company is not only the weather data providing company, but we are providing solutions of weather data in various segments. Those include agriculture, renewable energy, aviation, logistic, transportation, any segment you say, we have the solution based on weather data. All these data solutions are provided through cloud. Now, the weather company, all offerings are migrated to the IBM cloud. So IBM cloud is supporting all these infrastructure, and we are up round the clock without any downtime. Right? We divided the Earth into 2.2 billion grid points, and every location, which is a hyperlocal location, every 500-meter by 500-meter resolution, the weather data is available. So any place let long given, and there the weather data is available for the given location. So now every location what we see across the world, we provide around 40 plus weather parameters at every location, which include the rain, precipitation, or temperature, humidity, dew point, wind, visibility, cloud cover, UV index, moon phase, moonrise, sunset, sunrise, GHI is being used in renewable energy, weather severity, and so on. Any parameter one needs, we provide all the parameter. So across the world, all the parameters with the update of every 15 minutes, that's the scale what weather companies providing the weather forecast, right? How to get the data access? So any place let longs are being preferred. So if we know any place let long, one has to change in this URL. We give everything on cloud solution. So based on API request, one can access the weather data. This URL can be used for access the weather data. So 15 days forecast can be obtained using this URL, where geocode is shows the location where one is interested to fetch the forecast. The output format is JSON format, which is easily integrable in any mobile app, dashboard, web page. Units, IBM Weather Channel supports three kind of unit: metric, English, and hybrid. So different part of the world, different units are supported, but here user has option to select the unit. Language, right now it is selected as English of US, but we provide around 60 languages across the world, including few regional languages in India, which are supported by the IBM Weather service. Now the last is key. So we give the any user the API key. One can get those key and fetch the data. It's so simple. Nothing else needs to be done. The output will be JSON format, as I said before, which is easily integrable in company's application. Now I would like to talk a little bit about AI, how AI being used in the IBM provided weather forecast. So as I said, we have around 178 model or 170 plus model. The number varies here there depending on the time and the time of the day and when we are looking for. But those models and those output vary in terms of resolution, in terms of frequency, in terms of the methodology used for getting those forecast data. So first thing first, we need to fuse all the model to make on a same forecast. Then we need to verify whether the forecast provided by those model making sense or it's a garbage. And based on that, finally we need to assign some weightage for each model, and then we need to find the right forecast which can be used at the given location, right? So generally the standard equation which is used is we need to find the bias first in the forecast if there is any. So that bias is being estimated by using the forecast and what is the actual forecast. So our algorithm continuously update the bias by taking the actual what happened to the day, whereas what the provided as the forecast, so that what difference was there, the bias is estimated based on that. And same way, when we realize that which model working well, the weight is given according to that model, and it's all dynamic, operational. So that's how the final forecast is derived using those many ensemble model. Um, for example, if we want to know the temperature at noon on a given day, there are various model. Each model is giving the temperature. Some says 60 degree and some says 50 Fahrenheit and so on. So how to derive for the one what we do is we give the weight for the each model, uh, and then respective model forecast, and after weight how they look like, and based on that the final forecast is being derived, right? The bias corrections is being done, weight is given, and then we derive the final forecast. The next is I would like to discuss about the IBM Graph model, which is recently launched, and this is a unique to IBM, which is an application of IBM high performance computing system capability, then the modeling work what IBM scientist has done, and then how it is updating the continuous forecast, which is helping to provide most accurate forecast weather data by IBM Weather Company, and which enables users to have solutions in their respective domains, right? So this is the weather model which run across the world on 3 kilometer resolution. Let me means there is a in a world hardly any one or two national agencies they are running their model at 3 kilometer resolution. Otherwise, most of the government agencies across the world they run the model at 10 kilometer resolution. So we are, and then those agencies in general run the model at their for their country. But where IBM is coming, IBM would like to run the model for across the world because weather doesn't have any geographical barrier. One country's weather impacts to another country. That's why IBM is running the weather across the world. Right now, it is being used for 15-hour forecast, but soon it will be used for longer terms. It is being updated every hour. So if you see any national agencies, they generally update forecast 4 times in a day. Whereas this model using IBM high performance computing capability, it is able to run the model every hour. And then frequency of output every 5 minutes we store. It is operational since last year, November 2019, and that's being used. So these are technical details about the model, what data simulation technique and dynamic core. So this model is called MPAS and when IBM implemented, we call it as IBM Graph Model. It is being implemented on IBM Power 9 based system, which is uh, a hybrid system in terms of CPU and GPU. GPU is a graphics processing unit on which the number crunching is being done. So IBM Power 9 system, which has many GPU, those GPUs are being provided by NVIDIA, and there this weather model is being ported. Now it is the first weather model across the world which is running on GPU and operational. It is the first model which run across the world operationally, as well as it's the first operational model which is running on GPU and CPU together, right? So these are little more detail that this model has a variable resolution. It can run over land at 3 kilometer and over ocean it's a 15 kilometer. And this is MPAS as developed by the NCAR. IBM collaborated with the NCAR, National Center for Atmospheric Research, and NVIDIA. And then we ported this model on IBM system. So here are the agencies which worked with IBM to port this model. So NCAR, University of Wyoming, NVIDIA, IBM, and the Weather Company. This collaboration only lead the MPAS that is accelerated on GPU. So without GPU, every hour update was not possible because everything on CPU there is a limitation in terms of heat, in terms of number crunching. So that's why it is being used. Now to make the things work on GPU, the OpenACC directives were used. You can see the right side how the original code was, and after inserting OpenACC directives, the code there are around 2,600 directives being used. So accordingly, the code lines are increased. Right now, it took around 2 years to make it offloaded on GPU and make it work. And now this is operational, and the graph is available for run the operational on GPU. That's what it is. This collaboration lead to a system size. So approximately the system has 76 GPU node, which each GPU node has a 4 GPU, right? So 76 into 4, those many GPUs are there. They are Tesla V100. We have per node 16 CPU node, that is Power 9 system. Then there is a 256 DDR4 memory, and uh, then on the nodes which has CPU and GPU, there are 2 into 20 cores, so 40 core system that has. So now I would like to show where this graph is helping. So this is the live example. Uh, I am showing over India how the graph is helping. So left side is the resolution, standard resolution being by any national agency around 10 to 12 kilometer resolution, right? And the right side is the resolution, high resolution, 3 kilometer IBM graph model. This is the result from IBM graph model. So in this picture, I will show you the difference with higher resolution model and frequently update of the model. First, let's try to see the bottom of the screen. If you see on Sri Lanka, there is a wind stream coming. This is Sri Lanka. And here the wind stream is coming, which is visible only in this graph model, which is not visible in the coarser resolution or existing resolution model. You see this wind stream that is going over Sri Lanka. It is not at all captured by the coarser resolution model. So we were not able to capture the weather phenomena more accurately before, because the resolution was coarser and frequent update was not there. Similarly, if you see the center part of India, there is, if we see the coarser resolution, it shows the bigger area where it may rain, and so darker the color, it shows the higher the rain, but it is showing the bigger area where it may rain and gives the tentative idea, this red patches and all. If you see the right side, we are showing the small patches, red patches, so it shows clearly at which location and how much rain will be there, and that makes more accurate hyperlocal weather forecast, right? An example of this, what we did is we worked with the Ministry of Agriculture in India, where we provided the weather forecast to the 400,000 farmers. And they were receiving the weather forecast every day for next 7 days to plan their activity on the field on their mobile phone through SMS. So IBM worked with the Ministry of Agriculture, where on their portal IBM enabled the weather forecast and weather keys and all URL link for a particular reason. And then the ministry fetched those forecasts and provided it to shared with the farmers. So scale was every day 4 lakh farmer was receiving the weather forecast. And finally we collected the feedback. So the farmer appreciated, and that helped them in their decision making, like when to irrigate, how much to irrigate, then when to do harvesting, and so on. So that's where now the graph is helping to provide the hyper local weather forecast for the farmers or any user in any domain. One more use case would be that in the renewable energy segment, one has to predict the energy requirement at least 24 hours before, based on the Indian government rule in the exchange. Now, to have the hyperlocal requirement of energy in the given area, one should know the temperature and humidity in advance, because higher the temperature, the geyser runs more, which warms the water, and if the higher the humidity, air conditions run more, the requirement increases. So accordingly, so to know the hyperlocal weather, IBM Weather is helping the energy companies to know exactly what will be the weather for next 24 hours at the given location, and accordingly those being used for the weather forecast, right? So this graph model is being used, as I said, right now it is being used for 15 hours. So more focused is from next 6 hours. What is the forecast? It is being for all the mobile devices, on television, then on internet. We have dashboard, IBM dashboard. Through that we are providing the forecast. and then the turbulence for aviation industry, where will be the turbulence, and for that also the graph model being used. There are few examples of IBM graph model. With that, I would like to end my session. Thanks for listening. Would like to know if there is any Q&A. Feel free to ask any questions.